we hear the word IoT, a lot of times we think of is like smart home devices. We think our smart door locks or doorbells or anything. But another place in IoT that we often quite use that we don't really talk about is actually within the healthcare space. Joining me today, we have our partners from Ezurio. Andy, thank you for joining me.
No problem.
Here we wanted to basically kind of talk a little bit more about how to design a healthcare device. The analogy I was thinking is something really is traffic. Each car is sort of like a data packet trying to reach its destination. It encounters traffic, congestion. Within a normal home, a little bit of traffic, but not as much as we would expect in the healthcare space. Comparing like the healthcare environment, it's almost seeming like in constant rush hour, right? So kind of the first question is like, how do we deal with this traffic?
There's a number of ways. The most obvious one is just avoid it, because your Wi-Fi is a collision avoidance process. They don't want these things bumping into each other because you lose data and stuff. And so with the latest technology, the Wi-Fi 6, specifically the 6E, they opened up the 6 gigahertz space. This is 1.2 gigahertz of RF bandwidth that can now be utilized by Wi-Fi that wasn't there for the previous generations. The most obvious tactic is
just kind of avoid it altogether.
Yeah, avoid it altogether. Go on the clean road, right?
Okay. So kind of like basically, bringing it back to the traffic analogy. So like each lane is essentially kind of like a frequency band, right? Like building up to Wi-Fi now, we have 2.4, we have 5, and then now with 6E, we have the 6 gigahertz band. Yeah. So it's kind of like each lane is like kind of its own like kind of protected lane, essentially. So if we're not in the commonly used ones, we're in a brand new one, avoid all the traffic all at once. As kind of devices come online in the future that utilize 6 gigahertz a little bit more, we still have to navigate congestion a little bit, and kind of a lot of that comes down to hardware, making sure like the RF performance is there, right, to be able to kind of.
The next thing outside of just avoiding traffic is making sure that your ability to drive down the road is really good, and that means RF performance. That means your transmit power, your receive sensitivity, and a thing called link budget, which is really, how clear is your information being delivered between you and the destination. The Infineon parts have tremendous RF performance in 2.45 and 6 gigahertz, which bodes well for anybody using them. It means, yes, you get all the goodness of the Wi-Fi 6, but you have a quality car. You're driving down the road, with a Mercedes.
You're not just avoiding the traffic, but then you also need to have something to take you down that road, essentially.
So the Infineon, specifically the 55513 part that we use, is a very good part for that.
Gotcha. Kind of answers the question, how do we get connected? And then sort of now kind of moving on to sort of the next step is right now we're able to have this connection, right? And then kind of with a lot of IoT devices and now kind of one miniaturization, and that requires probably not being tethered and connected to a wall all the time, and the implication is that everything is now battery powered, right? And especially with a healthcare device where it's very critical to have your battery just not die midway through, especially when it's transmitting very vital critical information. So what are some sort of ways we can sort of help making sure our devices stay powered?
So you're dead right, Jerry. They've had in healthcare space battery powered equipment for a long time. They set limits on their use requirements. So they'll say, for instance, hey, this piece of equipment needs to work for a full shift for a nurse, or 2 shifts for the hospital being open, or a particular situation. And those guidelines continue to exist. But what's changed is they're not comfortable, or they don't want to maintain having to run a bed or a pole that a battery's attached to. Now it has to be connected to the patient. Your comments are that as things get smaller, the batteries get smaller, and therefore the available energy gets smaller. And so it becomes very critical for the equipment manufacturers and ourselves to be able to deliver solutions that are efficient.
Using the resources you have available, not just kind of wasting it, and just really making sure it's...
You're making sure you get
you're squeezing every ounce of it.
Every ounce of juice out of that battery, and that it allows you to make sure that you don't sit in a situation where the little red light goes on. Inside, for instance, the 55513 device, they use a very efficient transmit power circuitry. Our IF513 device is actually our lowest operating power and lowest standby power Wi-Fi 6E device. So this is a tri-band part that we have. Very effective, very power efficient. It has features in there that work very well. It includes support for what's called the 20 megahertz bandwidth.
Yeah, I wanted to kind of touch on the 20 megahertz one. So,
yeah.
you know, in Wi-Fi, I've heard about 40, 80 megahertz before. The analogy I was trying to come up with was basically, you know, what you think of as almost like a delivery truck. So, you know, let's say we have a package that needs to go to, you know, a home residence or something, and essentially one is we could use like a normal delivery van versus using like a full semi truck, kind of onto like the limited battery space, right? So we only have like 10 gallons of fuel to get there.
Yeah, exactly.
Right, and you're like with a semi truck, you're gonna burn through maybe, if not all of it by the time you get there, versus like, you know, a delivery van where you can
exactly
just
it. That's exactly it. Yes.
Okay.
The measurement of the performance of the device, you know, the 20 megahertz for a large portion of the healthcare applications, 20 megahertz is as a bandwidth is more than enough to be able to get them to deliver the data that they have. So they're not compromising the overall performance or the ability of the healthcare to be high quality and appropriate. They're just making sure it's as efficient as possible.
Everything's all coming together. It's all, and now we've addressed, you know, kind of performance, battery, and then you touched base on it a little bit earlier, which is kind of security, right? And, you know, even with our own personal data, you know, it's something that's very important to keep secure, and I imagine even more so especially in a healthcare environment where, you know, it's very critical, you know, information that's being sent.
So you're dead right, Jerry. Is security is, you know, as critical, you know, these days, and I think everybody's witnessed this, seen this on the news, that the incidence of people trying to get access to data that they shouldn't have access to is increasing as fast as parts are being delivered, and the demands on the security of the parts are increasing every day. The processes with the Wi-Fi that we do this with is there's the link between the access point and the client that needs to be looked after. And then there's the protection of the device itself. And both of those need to be addressed in a solution that's provided.
Well, maybe we can start with that portion first, the transport portion.
So security's been an evolving feature for Wi-Fi over its life, you know, as the demands from the outside world have been placed upon it. And we're at what's called WPA3 right now. The products that we generate and deliver to the healthcare market all support WPA3 Enterprise. There are various mechanisms and pieces and encryption types and ciphers and certificates that are all needed underneath that.
And then I think there's something I was reading about like forward secrecy as well. So like basically, if you do have someone who manages somehow to bypass all of that, right? Even though they're able to, like, say, like, make a copy of the key for one packet, you know, that they receive. Essentially, the key that they have only works with that one lock. It doesn't work for anything else.
Exactly, and it's constantly changing. And there are other mechanisms, which means that, you know, that the actual transmitter will periodically make sure that the person it thinks it's sending the data to
basically checks if they're still there.
Right, you're the real person, right?
Exactly.
There's lots of things, and it's evolved, and it's very strong right now. But the other piece of it is the device itself.
Yeah, and then in terms of, I'm assuming there's a lot of hardware, you know, requirements as well that needs to make sure that is, you know, everything that where it's coming from has to stay secure itself. So have kind of make sure on the module part, make sure it always has to ensure that, you know, it is secure on device. Yeah,
so the 55513 or our IF513 supports all of those features that Infineon delivers, and so one of the things that's very important is that only authorized firmware can run on the radio. And this is called signed firmware, so that a bad actor, a person that's trying to break in, can't hijack the endpoint and start pulling data off. And we fully utilize all of those features to make sure that any device or any customer that's using the device gets full access to the protections that Infineon's put in. And you know, an odd one, which maybe doesn't seem to make too much sense, is rollback, anti-rollback. The idea of anti-rollback back is that you move forward.
Yeah, you move forward. You never move.
And you don't allow the device to come back, because what happens if that in the back somebody discovers
like a new
break in
exactly,
it?
Yeah.
Oh well, we'll just roll it back and get access to it. That's a very important feature as well. Something that's 100% supported.
Yeah. Well, so basically, kind of what I'm taking away from this conversation is essentially, if I wanted to ever design a healthcare product, I should just go to you guys. You guys have the part ready,
yes,
modules ready, kind of just drop it in, and
absolutely,
all the stuff that we discussed today, I don't necessarily have to worry too much about. Well, thank you so much again for taking the time to join me today. So I really appreciate your expertise, Andy. So to find more information on the Infineon CYW 55513 or our Ezurio module partners, feel free to visit Infineon.com. Thanks for watching.